Okay, so I want to go through again some more examples of things that we looked at last spring in honors pre-calc, and just make sure everyone's on the same page. So some of these you might be able to do without even me going through, and if that's the case, pun intended, I don't want to limit you to doing them by waiting for me, but I do want to emphasize some of the notation that we're going to be a lot stricter on this fall. One of the things is that you have to keep this limit symbol until you've actually evaluated the limit. So if I know that I can factor the denominator, I want to show that. So I might say, okay, here's the limit as x is approaching -1 of, I've got x plus 1 in the numerator, and then I could factor that bottom into x plus 1 times x minus 1, right? I haven't taken the limit yet. So I want to show this step, and I still need to make sure I have this limit. And I'm gonna be very vigilant in looking for that, because you haven't taken the limit yet. You want to show me that you can cross that out, right? So now you have a reduced function. The limit as x approaches -1, and it's like 1 over x minus 1. So now I have a function that can be evaluated by just simply substituting -1. And so then, since I can actually put -1 in for that guy right here, I can actually let x be -1. I do not need my limit sign anymore, because when I put -1 in there, it's 1 over -1 minus 1, which is equal to -1/2. Okay, so that we say our limit value is equal to -1/2. Okay, so anytime you've got a factor, it's a little bit tedious, right? The limit as x approaches -3, and then you've got, I know the bottom is a difference of squares, x minus 3, x plus 3, and then this would be x minus 4 times x plus 3, and I realized I said the right thing in the bottom, didn't come up. Okay, now again, if you think about trying to put -3 into your function, -3 squared is 9, minus a -3 is actually a plus 3, so it's 12, minus 12, which is 0, and -3 squared is 9, minus 9 is 0. And I talked last fall and last spring that 0 over 0 is a really important number. It's an indeterminate form of a number. It's kind of masking what's really happening. And if you have a 0 over 0, that means you actually have a hole, right? And this is something we talked about in honors pre-calc, that hole actually is something that you can remove and still analyze the behavior of the rest of the function. So again, I'm noticing that if I can cross this out, notice what you just crossed out, right? Like if you think about that for a second, when x was -3, that would have been 0. When x was -3, that factor would have been 0. So you're sort of eliminating that 0 over 0. And you might say, well, wait a minute, we can't divide by 0. Yeah, and you're right, we can't. But the thing is, we're not, because this is defined for everything that's not -3. And notice that we're getting close to -3, but we're never at -3. So this is a legal operation. We can do this, and then I could say, okay, let's go back and say now we'll do our limit as x approaches -3. I've crossed those factors out of x minus 4 over x minus 3. Put in your -3. So -3 minus 4 is -7. -3 minus 3 is -6. So we have a value of 7, 6. That is our limit value. Now remember, this is the behavior of the function. This would be a y value, a y coordinate. So when I look at the grid at -3, the y value at that point would be 7, 6. But remember, this is really describing a hole, right? Because we crossed that factor out. So we would kind of mentally block, well, what's really happening at that point, right? We don't know, right? We're blocking that out, but we know its geographic location is 7, 6, and that fits the behavior of this function. Okay, so again, you could, just factoring is fine. So limit as x approaches -3, the top factors into x plus 3 times x minus 2, where the bottom factors into x plus 3 and x minus 1. And again, as we get close to -3, I should notice that there's a 0 and there's a 0 that can be reduced. And I get an equivalent function other than at one point at -3, and that's okay, because I don't want -3. I just want things that are close to -3. And so then now I can actually evaluate. Now that I'm taking the limit, I don't need this expression anymore. And that gives you -5. -3 minus 1 is -4, which is 5/4. And again, just to emphasize, that's a y value. That is the behavior of the function. Okay, then the last one, a little bit more maybe of a challenging factoring problem. I noticed I can maybe factor by grouping. So if you took out an x squared out of the first two terms, you get x minus 1. Take out a 3 out of the second two terms, you get another x minus 1. The bottom factors into x minus 1 times x plus 4. And then the top factors one step further. You could factor out an x minus 1, and then you get x squared plus 3, all divided by x minus 1, and then x plus 4. And again, I see that these cancel. So now I have an equivalence statement. The limit as x approaches 1 of x squared plus 3 over x plus 4. And as we let x go to 1, we get the numerator of a 4, the denominator of a 5. So we get a behavior or a limit value equal to 4/5. Okay, so factoring is one of our most common ways to analytically evaluate a limit, and especially when there's a hole in the function. And again, going back to that example B, it looks like, when is there a hole? When you can get 0 over 0. Okay, now there are other ways to analyze that, and another one is when there's a square root, right? So if you think about putting 10 into this, 10 minus 1 is 9, the square root of 9 is 3 minus 3 is 0 over 0. So I do have a hole, and I should be able to remove this hole and analyze it analytically. But instead of factoring, I guess in a way, we're going to just multiply by the conjugate. And so then again, I realize, I understand, it is tedious. X minus 1 minus 3 is the problem over x minus 10, right? That was given. Now I'm going to multiply by the square root of x minus 1 plus 3 over x minus 10. And again, it doesn't really matter whether it's the numerator or the denominator that has your square root. So then limit as x approaches 10. This times this is x minus 1. And then the middle terms, because they have a positive 3 and a negative 3, they cancel. The -3 times 3 is 9. And then, oops, how many people caught my mistake? I just did. This should actually be the same as the numerator, which is x minus 1 plus 3. Remember that you're multiplying both numerator and denominator by the same thing. So it's like multiplying by a fancy 1, which doesn't change the identity. And so then I would leave it factored in the denominator, because eventually that's going to cancel. It's a super long square root there, right? Because x minus 1 minus 9, that is x minus 10. So I have an x minus 10. I have another x minus 10 here. So now I can actually cancel those two factors, and that's the 0 over 0 that I'm removing. And so then I get, okay, great. Limit as x approaches 10 of 1 over the square root of x minus 1 plus 3. And I can evaluate the 10. 10 minus 1 is 9. Square root of 9 is 3. So I get 1 over 3 plus 3, which is 1/6. So again, there's a hole at x equals 10, right? Because when I try to evaluate it, there was a 0 over 0. The y value of that hole is 1/6. So the limit as x approaches 10 of our function, if I call it f of x, is equal to 1/6. That's equivalent to saying the geographic location of the hole is 10, 1/6. So this doesn't really belong to the function, but it's like the missing piece. It's like when you went back to that calculator and everything was filled in but error, like the trend is that, oh, well, the error should have been 1/6. Okay. So, and I think there's like another example here. So if you want to pause the video, try it on your own. So, here's an example where the square root was on the bottom, and that's okay. But if you want to try it on your own, and then, fast forward, see what you get, certainly do that. Okay, so x plus 2. So I'm just being a little, I guess, lazy here. So I'm just going to multiply by the conjugate. So, but then I have new line. So limit as x approaches -1. Leave the numerator factored, right, grouped out, because I think it's going to help. There's those marks there. I think it's going to help x plus 2 when we cancel. And then x plus 2 in the square root. So it's just a normal x plus 2. The outside inside terms cancel, -1. And that is a factor that's going to cancel. Limit as x approaches -1. You have x plus 1. You have the square root of x plus 2 plus 1 all over x plus 1. And this would cancel, and we now have removed, again, thinking about that 0 over 0, x approaching -1, and it's the square root of x plus 2 plus 1, and then I guess there's still an understood 1 there, but doesn't matter. It'll eventually divide out, and -1 plus 1 is, -1 plus 2 is 1, 1 plus 1 is 2, so we get a limit value equal to 2. And again, that's the y component. So multiplying by a conjugate is also something that you need to have, I guess, as a tool to help you analyze a limit. So we can look at a limit from a graph, we can look at it from a table, and then we can also look at it algebraically if you can factor or multiply by a conjugate. And then I think either today or tomorrow in class we're going to talk about the squeeze theorem and get some trig identities as well. Okay, so I'm hoping that a lot of this did go smoothly, because some of it might look familiar to you from the spring. But if it didn't, go back and look at the videos again, right? And see if there's anything that you might have a question on, and then we can address that when we are in our class time together. Okay, thank you.